Well, hello, Internet, and welcome to my first live coding session on both YouTube and Twitch at exactly the same time. And today, what I'm going to do is I'm going to focus in on TensorFlow. And I am specifically aiming this from the beginning. I'm going to make it so that just about anybody that watches this can understand what is going on. As long as you have a little understanding of Python or some other programming language, you should be 100% fine. And of course, I'm here the whole entire time to answer any questions that you have. The only thing that has come up is that sometimes the resolution's better on Twitch and sometimes it's better on YouTube. So if your resolution isn't great, try bouncing over to the other site, try that out. And after this video is finished, I will post a link to all of the code and it will be on GitHub and everything. So the whole time I do this, then just feel free to ask any questions. Okay, so here we go. And the one other weird thing is that if you comment on YouTube, it won't show up on my screen, but if you do it on Twitch, it will. Sorry, I can't fix that. That's my software. It has a problem. All right, so enough talking. I'm going to show you one slide, and this will be the only slide that you will ever see across the rest of this video. But I think it's kind of important to conceptualize a couple things because I like to teach through coding. Is my background real? It is absolutely not. Okay, so here we go. Here comes the one and only slide you're going to see today. Okay, so what exactly is TensorFlow? And I'm dumbing this down and making it very understandable. Basically, TensorFlow is used for many deep learning, machine learning applications. And it's basically what it does to simplify everything is it uses a bunch of numbers to predict another number. And we'll get into why everything is numbers as the tutorial continues. And you can see here an example of a neural network on your screen. And basically what we're doing here is we're demonstrating a situation in which our neural network is taking in certain input neurons, which are going to be the number of bathrooms, the number of bedrooms, and the square footage for our house. And then it is going to ultimately spit out a prediction on the price of said house. Thank you for following. Okay, so what is an input neuron? You can mainly think of this, at least in the very beginning when you're learning about machine learning, is what we're trying to do in the beginning is to plot a regression line that fits the data points that we provide to our system, our model that we are going to be building. Okay, and what by regression line, I mean that it is taking all the different data points and it's finding a mean value between those points. And when I talk about input neurons, I just mean the number of features that are going to be used by our neural network to make predictions. And by features, as in our example we have here, those features would be the number of bathrooms, number of bedrooms, and the square footage. Then you have in the center, those three columns. Those are what we call hidden layers. And what they do is they apply different weightings to our feature. And by weightings, I mean how important certain features are to estimating the price. Okay, so it's going to say, okay, let's maybe if we apply more importance to bathrooms versus square footage, does that help us ultimately get our final price? All right. And output neurons are just the predictions our neural network makes. And that is the end of you seeing any slides. All right, it's just I do not like slides. I don't like to use them, but sometimes I have to. And for those people that are saying, well, what if I don't have a really good computer? Can I do this? Yes, you can. You can use something called Google Colab, which is what I am going to be using in this video. And I'm going to be using all original data as well. When I say features, I am saying that that input data that is going to influence maybe the price of a home. Or as the example I'm going to use here, I'm going to use the NBA, and I'm going to try to predict basketball salaries based off of analysis of different statistics. So in that situation, the statistics, the number of three-point shooters, NBA, I'm referring to basketball. the percentage of three throws, three-pointers that are achieved, the number of points, the age, the team, all of that would be features in this example. So the features are just all the inputs that we would receive. I'm going to be using Python 100% across the entire course of this tutorial because that's what I use. I'm an inventory analyst and I use Python and I use TensorFlow, PyTorch. I use a whole bunch of other different data science platforms to be able to make all my predictions. All right, so what are we going to do here now? Well, you might ask yourself, well, what is a tensor? And I think this kind of explains it pretty well. Now, if you ask your computer, if you provide an input to your computer, your model, and that is the color pink, your computer does not know what pink is. But, however, it would understand the concept of 100% red, 0.075 green, and 0.079 blue. And we are going to represent that data in a format like this. Okay, so this is how we are going to be translating all of our things that our computer can't understand into numeric data. Are your predictions accurate? Well, they are going to progressively get more and more accurate as we continue. Whenever we first start out, they're not going to be very accurate. But that is why that's the whole process. And that's sort of going to be true no matter what data we ultimately analyze or what we are ultimately trying to predict. We are going to learn over the course of this video many different things that we are going to have to get better at. And those things are going to change depending upon the type of data that we are working with. Yes, those RGB values in that specific situation represent a vector. And you can see here some examples of how we will use tensors. This is a vector, this is a scalar. Matrix would be like a multi-dimensional array or like a matrix. And a tensor is a multi-dimensional array of vectors. Here are all the inputs that are imports that I'm going to be using. So of course I'm going to be using TensorFlow. I am going to be using also Keras. All this code is going to be available on GitHub after the video is done. I just have to upload it. I am going to also be using NumPy. I'm going to be using pandas, and I put all of the different pip installation tricks you would need if you decide you don't want to use Google Colab. So there's pandas. I'm using Seaborn, Matplotlib. I'm going to be using scikit-learn for a whole bunch of different things that I will cover as the tutorial continues. I would explain more exactly what these are doing, but I think it makes more sense when you see them in actual code and in actual examples. And what this guy down here does is it actually tests to see if I'm using Google Colab, a Google Colab GPU or not. And I'm going to run this, and you're going to see that it checkmark came here, and I did not use the GPU. I'm probably not going to use the GPU, but if you would want to use a GPU, you could just click up on in this area right here, and then you are going to be able to use that. I am not going to use it, though, because I have no reason to use it. All right, let's get that out of here. Okay, so here's some Google Colab sort of fundamentals. Okay. And this is just some ways to work around inside of Google Colab. So if you want to change to a markdown cell, what you're going to do, like this, if you go and actually focus in on any of these different pieces, this is what's called markdown. And these two hash symbols here are going to allow us to bold that. And then to run all of your cell, either this or code, you just hit Shift and hit return. It's exactly the same on Windows as well as on Macintosh. All right, so there's just a couple little things, and as we go through here, I will explain more about what I'm doing as I'm working with Google Colab. Now, the very first thing we're going to need to do is we're going to need to download our data. And I'm not answering questions about net worth right now. And the data that I provide, here it is. You can see it's going to be on GitHub. And I can go and paste this if you want to be able to get it. So it's going to be here. I'm working with two different chats, so it's a little bit weird. But this is the very first time I've ever did live coding on 2 different platforms at one time, so bear with me. So this is where it is. Okay, so this is just a bunch of NBA stats. This is stuff that I went and put together on my own. And you can see all of the NBA players and the insane amount of data we have on every single NBA player. And our goal here is to figure out how to predict salary based off of, you know, all the other statistics that we have. But to be able to access it, you're going to have to click on raw right here, and then you're going to get this. And you're just going to select it. And this is the way, this is all CSV data, comma separated values. And then we're going to jump back over inside of here. And I'm going to show you exactly how we are going to import all of the data that we want to work with. So I'm going to say NBA data is going to be equal to, PD stands for pandas. I have a gigantic pandas tutorial on my site if you'd like to get it. Read CSV. This is how easy it is to read a CSV file. And then you just paste in that information. Now, whenever we do this, of course, we would like to, that's just the, you know, the link to what I just showed you. Now, anytime we do this, of course, we're going to want to come in here and verify that we were actually read the data. Now, if I just want the first 5 pieces of data or rows of data, I'm just going to type in head and run it, and you're going to see that, yes, indeed, I was able to grab all of this different data. Yes, I created this data set. This is, I scrubbed it off the internet. It was kind of hard. I was originally going to do baseball, but then I decided to do basketball because it was a little bit easier to work with. Sorry, I have to drink tea or I will lose my voice. So yes, my data set is available for anybody who wants to get it. All right, so after I go and get that, then what I need to do is I need to delete unknown values. Like I said, I don't think you need to really, I don't think you really need to understand any of the data science or really anything to be able to jump into this. It's going to be very, very simple. So to delete any data that is you know, going to be missing, I'm just going to go NBA data dot is NA and dot sum, whoops, is NA, whoops, a little mistake there, dot sum like this, and this is going to tell me if I actually have any of these missing data in any of these different columns, and you can see right here I have none. All right, so all of my data is very clean. That's not normal. It's mainly because I already went and got rid of most of it. But let's come in here and let's say we want to go and delete data. How would we do that? If we did not get zeros in all those, well, we could do something like NBA data is equal to, and then we could say NBA data and drop NA. And that would get rid of any of the problem data that was in our data set. But we don't have any, so why worry about it, all right? Okay, and I could just get rid of this altogether, and I'm just going to click this to make it hide. What else do I want to do? Well, there's some data inside of this, as you can see up here, that I do not need. Remember, TensorFlow and deep learning platforms in general, they only care about one thing, and that one thing they care about is numeric data. So we don't care about first names and last names. We might leave, I'm probably going to get rid of the team and also the position out of here as well. Or do I want to? I might not want to, actually. Let's leave team and position in here, but we definitely don't care about first and last names. All right, so let's come in and let's delete some unneeded data out of our system. Imagine the size of the data file Google has on me. I think I'm extremely boring. So and Google advertisements are normally terrible in regards to what they send me. I don't know. Okay, so we're going to call this NBA data numeric. I did call this NBA data, right? Yes, I did. So I'm going to call it NBA data numeric just to signify that I am working with numeric data. So I just go NBA data like that. And I'm going to copy over all of that data to NBA data numeric. And then what I'm going to do is I'm going to delete certain columns. Let's go MBA, data, and numeric. And I'm going to say that I want to get rid of the first name. I don't want to, well, you're going to see, don't do that. You're going to see in a bit here what I am going to do to be able to convert the non-numeric data into numeric data. But I don't have any reason to use first name and last name, so I'm not going to use it. So I'm just going to come in here and let's get rid of that. And I'm going to keep position and name. You could get rid of it if you wanted to. Okay, and then just to verify that it actually is all gone, I'm going to go MBA data numeric, and you can see right here I have team, I have salary, I have position, and all of the other data. Now, I'll get into why I'm going to be changing this. Now, one potential problem you could come upon whenever you're working with this type of data, especially salary data and things like that, is there may be dollar signs, there may be, you know, unneeded commas and so forth and so on. So in those circumstances, even though I don't need to do it right now, I am going to create a custom function just so that if you ever need it, you will be able to use it. How many inputs do you think you would need to ensure a model can learn price action? Oh, that changes. That is completely different depending upon the data set and what you're working on. There are no ironclad number of inputs. Sometimes too many inputs, actually most of the time, if you have too much data input, that actually is negative in regards to your results. So that's a big problem a lot of the time, okay? But we're going to create a function here that we may or may not need, and it's going to be called, I'm just going to call it clean currency, because it's very common for us to receive you know, currency data, and we have to get rid of those dollar signs and all that stuff. All right, so what I'm going to do is I'm going to say if is instance and x str, and what this is going to do is if a string has a dollar sign in it or any delimiters or otherwise, it's going to get rid of those things. So it's going to get rid of dollar signs, and it's going to get rid of commas, and it's going to replace them with nothing. And otherwise, if the whole entire piece of data is numeric, it's just going to return that. All right. So this is one way that we can very easily clean up our data. So I'll say return and x replace, and if it finds a dollar sign, I'm going to replace that dollar sign with nothing. And you can stack these guys. So you can say replace once again. And if I get a comma, I want to replace it with nothing. And there it is. All right. And then after I do that, I can just say return x. All right. Good stuff. And we can run that. And then what I'm going to do is I'm going to come in here and actually run this on the salary data as if it was bad data, meaning that it was data that had dollar signs and so forth in it. So I'm going to say NBA and data. And whenever you're working with machine learning and data, deep learning, whatever you want to call it, you are going to be doing a lot of data cleaning. It's something that happens a lot. And if you watched any of my data science videos, you saw that I spent a lot of time, especially in the beginning, cleaning up data because it has to be clean or it will not work. All right, so I'm going to go through, cycle through all of my salary column, and I'm going to apply the clean currency. It sounds like I'm doing something illegal. Clean currency function, and then I want everything to be converted to a float. So I'm going to say as type float, and I assume you know what a float is. And we can come down here, and then we can say NBA data numeric and run all this. And you're going to see that I know there were no dollar signs there, but let me tell you, it's a very common thing that you need to get rid of dollar signs and commas, so that's why I decided to cover it. Just checking to see if I got any other questions. Data cleaning is just what I just did. Like, for example, everything needs to be in a numeric form. and it can't have things like commas in it. It can't have things like double decimal points. It can't have commas. It has to all be cleaned. And you're going to see also, whenever we go along later, we're going to be using something called Hot Encoding. And why that's important is, okay, so we have all these different data points. We have age, which is 22. This is 73. Then we have 1725. Then we have 0.595. It's like, wait a minute, this is completely crazy. And all of the ranges for all of these different data points are all completely different. You can't work with that type of data. That data needs to be what we call normalized, but I'll get back into that later. Also, maybe we want to work with team. Maybe we think team is something that's important or position's important. Well, guess what? This is a C. Last time I checked, C is not a number. Tor for Toronto. Can't use that either. So what we're going to need to do is turn these also into numbers so that we'll be able to better work with them. Don't worry, I'll cover everything as we continue. Yes, getting rid of all the unwanted data and normalizing it so that everything is in a common range, normally between 0 and 1. Sometimes -1 and 1, but you know, it depends. Okay. So now, after we did all this, let's say we wanted to get the overall shape of all of our data that we have here. Well, we could just say print and NP, which stands for NumPy. And again, NumPy is just a library that provides all kinds of awesome tools for us to be able to use. And we can just go, whoops, data numeric. Well, now it's not giving it to me. Silly thing. Okay. Let's run that, and you can see there is the overall shape. Let's say that I would like to get an overall summary of all of my different data. Again, something that is extremely important to be able to do. Well, I could just go NBA data numeric and dot describe. And you can use all this as a cheat sheet whenever I upload it. Okay, so it's going to give me the counts. It's going to give me the mean, standard deviation, minimum values, all of that. Maximum values, you can see right here, the oldest person in the NBA is 38 years old. The youngest is 19. You can see the mean age is 25. And the same thing is true for the number of games started, and all of that stuff. and let me be honest, I don't even know what MP means. Doesn't matter. You don't always need to know what all these things mean. This is field goal attempts, field goal percentage, 3 points, 3-point attempts. You know, I know most of this. Steals, blocks, turnovers, PF, not sure. Points, there's points. Okay, so now what we're going to be doing is just analyzing our data to sort of get well accustomed to it. And one thing we can do, I'm not going to delete the live stream. Don't worry about it. And what I'm going to do also is I'm going to analyze all the data with Boxplots. And why that's important is we want to be able to see how many outliers we have in our data. And by outliers, I mean those extreme values. Like, say there was one person, okay, we see the average age in the NBA is 25. Let's say there was one magical person who was 56. I don't know. All right, and everybody else was near 25. Well, that one person's insane age could dramatically affect our overall results. So we want to use Boxplots in the beginning to analyze our data and see if the data has a ton of outliers. That will be a sign that we probably have a problem with our data, and we're probably going to have problems later on, and we're going to ultimately have to get rid of those outliers. Matches played. Will you upload calculus video? I have no idea when I'm uploading a calculus video. Sorry. That is an insanely complicated topic to cover. Every single potential calculus problem you could ever see ever in one video. It's a lot. So I apologize, but that is something that's almost impossible to do. Okay, so what I'm going to do here is I want to have a bunch of rows. I have to get a drink of water. I'm going to lose my voice. Okay. All right. So I want to do a box plot, and I know that I have 27 columns here, and I have 8 rows. And so what I want to do is I want to plot a whole bunch of box plots all at one time. So I need to define, based off of those numbers, how many columns I'm going to have and how many rows I'm going to have. Well, the closest I can get to that is the number of columns being 7 and the number of rows being equal to 4. I then want to define exactly how big my overall graph of box plots is going to be. I'm going to say something like figure size is going to be equal to, and I'm going to say something like 30, 20. I know that's going to be too big, but whatever, who cares? Then I need to cycle through all of this data, so that is my index that's going to help me do that. I am going to also call axis here and axis flatten, and this just pertains to how close together the box plots are going to be. And then I just need to cycle through all of my data. So I'm going to get 2 values out of my NBA data numeric field, whatever you want to call it. So I'm going to say in NBA data numeric. So there it is. And items. So I'm going to cycle through every single row that I have, and I'm going to pull out all the data I need individually for each NBA statistic, and then I'm going to print out box plots based off of that. So let's go items, and I might need to get rid of the team information now that I think about it, and position, because I think this is potentially going to throw an error. So that's what I'm doing there. I'm cycling through all those rows and grabbing each individual piece of data, and I'm going to print out a box plot for every single one of them. And then I'll explain more about how those work. So SNS and box plot, and Y is going to be equal to K. And you'll see whenever this all prints out. And data is going to all come from NBA data numeric. I don't know why it keeps messing that up. Okay. Numeric, and axes is going to be, axes and index, and then I need to increment my index, of course, by 1 so that I can jump to my next row. I wish I could just shut those off. And then I need to, after I cycle through all these, I'm going to plot out everything. So I'm going to say plot tight layout. Again, tight layout is just going to smush all the different box plots up together, and then I can define exactly how much padding that I want to have on each of these. 0.4, and how do I shut that off? When I take a break, I'm going to look at how to shut off all those tips because they're messing up my code. And the only reason it's doing that is because I'm zooming way in on this code right now, and that's the reason why it's giving me that messed up look. H and horizontal padding, I'll make this be 5.0, and I think that is everything that I need there. And let's run it. I think I might get an error. Yeah, I did. And the reason why I got an error, see, it's not showing that. I need to get rid of the teams and some of the team and position. I didn't get rid of that previously. I'm sort of wondering if I'd have to get rid of that. Okay, so let's just come in here and we'll go delete. Yeah, the IntelliSense is kind of doesn't have any sense. I don't pay attention to that. I wish it would just turn itself off. I normally have it turned off. Normally I use Visual Studio Code, but I wanted to show you guys what Google Colab looks like. So that's the reason why I'm using Google Colab, because, you know, then everybody can participate in this, and you can borrow Google's servers and instead. All right, let's run that. And I got rid of team and position, so now I don't have anything except numbers, and I think everything here is going to be perfectly fine. I'm going to run this again just to do it, and 289, that should be there. Oh, we got rid of the 2, so I got rid of those columns. And I'm just rerunning all this. Let's go and run this again. I might have a little typo inside of there. Let's see. Kind of complicated to Well, no, I don't. No typos. Okay. So here is a box plot for every single piece of data. Sorry, I know this says salary here and you can't read it. But basically, those outliers are going to potentially cause a lot of problems for us. And the reason why is they are, it's kind of like bad data. And I can look at this right now and tell you there's a lot of very overpaid MBA stars. That's just looking at this. That means there's a lot of people, especially those people earning a considerably high amount of salary, they're overpaid based off their statistics. So that means we're probably going to have some problems later on. And as you can see here, basically the box plot's just going to allow you to compare different variables or features. And the boxes are going to show the quartiles of the data. The bar in the middle that we have right here is from the median. And then you're going to have whiskers. That's the lines that go up above the median main piece of data where most of the data lies. And the whiskers are going to extend to all the other data aside from the points that are considered to be outliers. And this is a great, wonderful way to really look and see if you're potentially going to have problems. Like we can see here, all right, salary, which is what we're trying to find, that has a ton of outliers. So that means it's probably going to be pretty hard. Age doesn't. So if age is a good contributor to ultimately salary, that's going to be a very good statistic that we can use to analyze our data. A lot of outliers for field goal percentage, a lot of outliers for 2 points, a lot of outliers in general. All right. And I'm specifically picking this data set because I want to create a data set that isn't easy to work with. And I can also go in and use histogram plots to also go and analyze this data. And then we're going to do a correlation matrix. And then I promise we're going to get into the actual meat of the machine learning. Let's see. I'm just looking at your questions you have here. What is going on? All right. Is there any chance you could write bullet points describing the step-by-step process? Yeah, I'm going to have all that. So yes, you're going to see bullet points for everything as we continue onwards here. All right, so let's get back to actually writing some code. Now what we're going to do is we're going to create a histogram plot. And we can use histogram plots to analyze how values are distributed into different bins. And then I'm going to show if the data is normalized or not. And if you want to predict a label, so in our house example, if the number of bathrooms and number of bedrooms are the features, the label is the ultimate price of the house. Okay, so anytime I say label, you think of what we are trying to predict. Now, what we want to see in our histogram plots is the data we are using for predicting salary, that it is going to have a very similar histogram plot. All right, so let's go and let's plot those things. So I'm going to, again, this is the same sort of stuff. This is just boilerplate Seaborn ways of plotting information. So I'm just going to go plot sub plots. I'm going to use a whole bunch of plots just like I did before. Number of columns, I'm going to use 7 because that worked for me before. Number of rows, I'm going to use 4 because that worked before. Figure size 30 by 20 actually worked. So let's just keep that. And let's see, it should work again. So 30 by 20. And always do that, figure size. So this is going to be figure size equals. There we go. And there we are. And again, we're going to do basically exactly the same thing. Index, we're going to cycle through all the different rows of data, and we are going to be printing out a histogram plot for every single one of the different things. So let's go. And anytime I ever work with new data, this is the very first thing I did. Rather than type all this out, why don't I just come up here and copy and paste this? So I'm going to grab this, and almost all of this is exactly the same. So I'm just going to copy it, paste it down inside of here, And if you have any questions hearing me or anything, I probably shouldn't have did that before. Just tell me. Okay, so this is going to be changed to histogram plot. And the difference here is this is going to be V. And this guy here is going to be, well, the axes are going to be the same for this. And I get more in detail into how Seaborn works, but don't worry about it. It's just boilerplate stuff. You don't need to worry about absolutely every single thing. You'll just get information overload if you try to do everything or learn every single thing. So I'll say density, and I'm going to say that I want my line width to be equal to 0. Everything is fine on its own. Index is exactly the same. And type layout, I don't believe I need to change absolutely anything with that either. And let's run it. Okay. And it is taking a while. Doing a lot of calculations to make all of these beautiful plots for you. And there we go. Okay, so what we can see here is salary. We have a lot of players making not so much money, and then we have a bunch of small number of players making a extremely large amount of money. So like I said, what we want to do is we want our data to be in a normal distribution, and that just means that, let me see if there's one that's kind of a normal distribution. That means that most of the data points are distributed along the mean, and you can see what I'm pointing at, right? Sort of. My head's in the way. Here, I'll move it up a little bit. Okay. Is there another one here that's on screen? There you go. This one's a normal distribution over here, this field goal percentage, all right? And that just means that most of the data is around the mean, the center of all of our data. And we are specifically hoping that our salary data that we have right here is going to be similar to the input that we are looking for. So we are hoping that 2 point attempts are going to be very contributory to salary. We're going to hope also, basically anything that looks like the salary graph, that's what we're hoping our data is going to work with. So then what we can do is we can see if that is indeed correct. How long have I been streaming? I'm running out of tea. I'm running out of everything here. Okay. I'm going to do one more thing. I'll do two more things. I'm going to take a brief break so I can get more tea, so I don't lose my voice, because this is going to be a long video. I'm covering so many different things. Okay, so how can we go in and check if our data is correlated? And when I say the word correlated, I talk about correlation all the time in all my data science videos. But that means the data is related to each other. And one way that I like to explain this is, let's say you own a candy company. Now, one of the biggest investments as a candy business owner is sugar. So if the price of sugar goes way up, that's going to affect your profitability, because you need to buy a lot of sugar. And if the main thing you're selling, if it's mostly sugar and the price of sugar goes up, that means that your candy is going to have to also go up. That means your candy prices are going to be correlated to your sugar prices. And likewise, if sugar goes down dramatically for some reason, well, then your profitability would go up, because the cost to make your candy also would fall. Now, the price of hammers would have absolutely no bearing, or the price of steel, more than likely, would have no bearing on the cost for you to make candy. So what we want to do, remember, we looked at this stuff. Well, first off, we looked at these box plots to see how our data looks and to see if there's tons of outliers. Very important. Then we wanted to go in and see what data inside of here is highly correlated to salary. Salary is the thing we want to predict, and we see all of that. See, I hope you see the value. Then what we can do is we can create what's called a correlation matrix, and it's going to tell us how heavily correlated each of these data points is to salary. I mean, it's so extremely valuable, all this information. Okay. And it's so easy to do. So we're just going to go in here and plot this. Figure size is going to be equal to 30 and 20. This is the box that I'm going to be putting all my plots in, except this is just going to be what we're going to be calling a heat map, what I like to call a correlation matrix. And then we just go NBA and data numeric and dot correlation dot absolute value, and annotation, I'm going to mark that as true. And then I can run it. And look at this beautiful thing that's going to pop up here and tell us everything we want to know. I mean, it's just great. Don't worry, I'm getting into the tensor. There it is. So now we can come up here and we can say, all right, we're interested in salary. Now this is a 1. Why is it a 1? Because salary is 100% correlated to itself. Let me just verify you can see what I'm doing. Yes, you can see what I'm doing. Okay, so salary is 100% correlated to itself, and likewise ages and all that stuff. So what we're looking at here is what other things are highly correlated to salary. Well, we can see 52% is games started, and there's 61%. What else do we got? 64% and 63%. So we can see right now we're starting to see what data we should use to make our predictions on salary. What we should use, maybe shrink this down slightly, even though you're not going to be able to see it, but I'll sort of be able to describe what I'm doing here. Let's try that. Recalculate, reformat that. Isn't it beautiful that you can use Google Colab to do all this? I mean, you have no idea how many thousands of dollars you're being saved. Well, that didn't even help. But you could see here, so here is 0.61. So that means that field goals is extremely correlated to the salary. I bet you points is also 0.63. Number of points the player scores is going to be highly correlated to salary. What's 0.64? What's more important than points scored? Free throws. Oh, the number of free throws. That probably means that player is getting fouled more often than not. So just looking at this data that we have here, I can tell you that free throws, points, field goals, and what else? Free throws, free throw attempts, but not free throw percentage. How crazy is that? And 0.58, turnovers, is going to definitely pertain to salary. So we got so much information. And one more thing I'm going to do here before I take a very brief break to get some more tea so I don't lose my voice, is I'm going to calculate the percentage of outliers, because looking at our data, that has really told me that is the most important thing that's concerning about our data is the number of outliers. So what I would like to do is calculate what percentage of outliers do we have with each of our data points. So I'm going to say for KV in NBA data numeric dot items. Again, this is just cycling through all of the different rows of data that we have inside of here. And this is a formula that we're going to use. What we're going to do here first is we're going to be using interquartile ranges. And what it's going to do is tell us the range of the middle half of my data set. So this, if we go up here to Boxplot, this is what we're interested in, this guy right here. And what we want to do is we want to find out what percentage of all the data points are outliers. So we want to find out what percentage of all this data here is this, okay? And it has big fancy names, but it's basically just a formula. All right, so what we need to do is we need to get our first quartile. That is the difference here. We're going to be getting this guy right here and this guy right here, okay? This guy right between this and that and that and there, okay? So we need to calculate those. How do we do that? I'm just going to call this Q1 and make sure I'm not getting any questions. Doesn't look like I am. Okay, let's move this over here. Okay, so let's go over and let's try to get this organized. All right, I'm back. So what I'm going to do is I'm going to go V and quartile, and I want the first quartile, so that's going to be 0.25. like that. And then I need to get our third quartile. So that is going to be Q3 is equal to V dot, and oh, it's not quartile, it's quintile. There it is. Okay. And all right, there it is right there. There we are. I was like, why isn't that working? And that would be 0.75. And then what I'm going to use here is a formula to get your interquartile range. I'm going to call it IQR. Then you're going to subtract Q3. Q3 is what I called it. You're going to subtract Q1 from Q3. And Q1. And again, this is just a formula that you need to use. And I need to go and find the lower fence as well as the upper fence. I'm trying to estimate this. This is what I'm trying to do, just to make this 100% clear. I'm grabbing from here to there. And then I'm trying to figure out what percentage of all of this is the outliers. Okay? Hopefully that makes 100% sense. All I'm doing is punching in a formula, though. You don't even need to know the specifics of the formula. Don't get your head all bent out of shape because you don't know it. It's just a formula. We're using a formula, all right? To do this, we go V, like that. And what we're going to do is we're going to say, is V less than or equal to Q1 minus 1.5 times the interquartile range. Okay? It's just a formula. And then we're going to do basically the same thing, but I'm going to type it out because whenever I copy and paste, sometimes I make errors. So greater than or equal to Q3 plus 1.5 times IQR. And I lost my parenthesis here. Get that parenthesis and throw the parenthesis here instead. There it is. And then I need to go and calculate the percentage of total outliers. How I do that, I'm just going to call this PER. And to do that, you just say numpy shape and V column and 0 times 100.0, and then divide that by MP shape NBA data numeric, and that 0 index on that as well. Did I get it all? Looks like I did. Sorry about the coughing, but that's because I am losing my voice here slowly. Yeah, I thought that was fine. I don't know why. And then what it's going to do as it cycles through is it's going to print out the total number of outliers for each data point. Outliers is equal to, and I'm going to say that I want 2 decimal places for the percentage that is kicked out of this guy. And I am just going to go percent, and I can say this is going to be K, and that percentage that we just calculated. All right, and let's run it, see if it worked. What did I do wrong? Cannot perform a data type of array, scalar type of float. What did we do wrong here? Typo probably. The column is V. Sorry about the complicated type of formula, but sometimes that happens. Q1 minus 1.5 times IQR. I know why. Because I needed to put parenthesis. I did need that parenthesis there. I got rid of a parenthesis that I needed. So let's go and throw this parenthesis here. And now all that should go away. And let's run it. Outliers, and what does it not like here? Print percentage outliers. 0.2. I'm not sure what I did wrong there. Oh, silly. There we are. Run it. There we are. And you can see here the salary has a 9.69 out. The percentage of outliers in the salary is almost 10%. Everything else was really pretty good. 10% is definitely the worst. Okay, so we know where we have our potential problems. And what I'm going to do next, after I take my short break, is I'm going to cover TensorFlow neural network regressions in detail. So I'll be back in probably 3 minutes. All right, I'm back. Thank you to everybody that stayed with me there. A couple of you. And I see that you can't hear me. All right, well, I'll raise my volume up. There, I raised it up, so hopefully you can hear me now a little bit better than before. Yeah, I don't think you need to be an expert in data science to be able to understand this stuff. Let's just verify a couple different things. All right, and then I will get back into the more TensorFlow side of all of this stuff. All right, so what did we learn? We learned a lot about our data. We learned that our data is going to be difficult to work with. We have a lot of outliers in the one thing that we're trying to analyze, which is salary. We learned a lot about what specific data points or features, get used to saying features, are most important in calculating salary. We used our histogram plots to see that our data is not normalized. Don't worry, we will normalize most of it. Boxplots told us we also have a lot of outliers there. Okay, so we know that we're going to have some problems with our data, but don't worry, I will get better, and we will get better and better. Okay, so a little bit of a review. TensorFlow neural network regression. Now, a regression is just going to be used to determine the relationships between different features in regards to how they will affect predictions that we are going to make. And I think everybody's, and let me see here, I'll go and I will grab one. So, regression. And whenever we start off, this is what we will be really looking at. Oh, I just clicked on the world's smallest regression. Let's go. Can I see this full screen? And I'm on Wikipedia. Yay. There we go. All right, so here it is. So this is a regression. I have no idea what this is plotting or what it's doing. But basically, what we have here are all of these different data points. And how we create this regression line is we take this data point and this data point here, and we sort of push them together to find the mean between all of these different points of data. And whenever we do that, we get a straight line. This is a linear regression because it is a line, a straight line. And we are not only going to be dealing with linear regression analysis, but that is where we will start because we have to start somewhere. And remember, this is all just using a bunch of numbers to predict another number. Whether it is number of bathrooms and number of bedrooms or square footage to the house price, or if we're looking at NBA statistics to try to make a guess on salary based off of those statistics. And there we go. So what I want to do here now is I want to get more into tensors and how to work with them and how to create them. This is from the ground level. So what I want to do here first is I want to create a constant tensor. And let's go and create a scalar. So we can say scalar, and we'll say TensorFlow dot constant and 5. There we are. And then we can say scalar like that and run it. And you can see that it is a 32-bit integer and it has a value of 5. Now we're going to create a vector. This is going to be the part of the tutorial where things just start getting really fast. So I'll just call this vector, and it's constant again, like this. And we can just go and say something like 10 and 10. There it is, and here is our vector. Run it. There we go. You can see the shape is 2 in this circumstance, and it's still a 32-bit integer. Okay. Let's go and create a matrix. So I'm going to call it I'm going to call it matrix. And that is going to be, and I'll make it a constant. I'll also show you how to make non-constant tensors. So in this circumstance, we are going to put our boxes around here like that, and then we'll just go 1 and 2 like this, and 3 and 4, just to do something. And whoops, don't get that guy there. Okay, and matrix. Boom, there we go. And we'll be manipulating all this data. Actually, I'm going to show you how to multiply matrices, and I'll explain why that is a useful skill to have. Now what I want to do is I want to create a tensor, and it's like a 3D matrix. And so I will call this tensor. That's where I wanted to put it, right? Create a tensor. Yes. So tensor and equal to TF. This is mainly what we will be working with, data that looks like this, because sending one piece of data doesn't make even partial sense in any circumstance. So we'll do here, and then in this circumstance, I'm just going to say 1 and 2 and 3. And can we rewatch later? Yes, I will have this on Twitch and YouTube, both. And I've also entertained the idea of potentially making a version where I don't talk that much. All right, I'm not that, but like an alternate version that's not live streamed. In case anybody wanted that. I don't know if I'm going to do that or not, because that's kind of a pain in my rear end. Okay, so what do I want to do here? Oh, I want to keep this this box right here. Just trying to figure out how I want to organize all this dummy data that I'm not even really going to do anything with. I'm just trying to organize it so that you guys can mess around with it. And that is really what you need to do to master this stuff, is just sit, hunt for things on the internet, and create bigger and bigger problems. I said I wanted to get rid of that, and I wish I would have gotten rid of it. Okay, so 7, 8, 9, and we'll just keep the party going here. 12, and this guy right here, and let's close that there, and like that. And thankfully we never do this. Okay, I'm just I'm just showing you what it looks like, but you will never sit here and type in all of this stuff. That's why I never do it. Anytime you ever see me struggling with something, that probably means I never do it. So I never manually type in a tensor. Okay, and neither should you. Okay, so there you go, and you can see the overall format of our tensor that we just created there. Now what I want to do is I want to create a tensor that can be changed. So how do you do that? Well, I'm going to call this v tensor for variable tensor, and you just type in tf dot variable, and just to keep this simple, I'm just going to do 5 and 6 like that, and v and tensor. Don't worry, we will be creating models here very, very quickly, or very, very soon anyway. Let's say you would want to go and either get or change values. How would you do that? I'm going to use print now in this circumstance. So I'm going to say that I want index of 0, and I am going to just go v and tensor and 0. And what else would I like to do? Oh, let's put that inside of there, like that, and like that. And if I wanted to change a value, I can just say tensor and 0, and follow that up with a sign. And let's say that I want to put 8 inside of there instead. And then I can go and print this out again, and you can see that the values, we were able to get the values, and also we were able to change the values. Okay, good. Now, another thing you're going to want to do whenever you're really practicing and messing around with TensorFlow and data science in general is you're going to want to be able to create random tensors. So I'm going to create one. So I'm going to say random tensor is equal to tf dot random dot generator. And then you're going to say from seed. And you may say, well, why do you want from seed? Well, let's say that you want this to be random, but you want to be able to get the same random tensor at some point in the future. That's what the seed does. It guarantees that the value, what you receive back, is going to be exactly the same. Okay, so that's why we use seeds. You can change that to any number you can want, and that's the only reason we want it, is we want to be able to reproduce these random number of values. Another thing you're going to be able to do is to come in, whoops, let's go up here, put that down there, and I will do this later on in the video, is you're going to be able to say TensorFlow dot random seed like this, and then it'll be a random set seed. Set seed, there we are, 66, and then that'll be a global seed that you will use throughout the code. And that's what I'm going to be using later, but I just want to show you everything so that you know everything. Okay, so now what I want to do is I want to generate values that are near the mean, which is going to be 0, and these values are going to create a bell curve, meaning that it's going to be normalized. So I'm going to say random tensor and equal to random tensor and normal bell-shaped curve. Did I say bell-shaped curve? That's what it is. Looks like a bell. Okay, is equal to 3 and 2, because you're almost always going to want to work with normalized data. So 0.0, that's what I said the mean is, and then I'm going to do a standard deviation, which is going to be just 1. Okay, and like this, and then we can just go and look at our random tensor and see how wonderful it is. And there you can see is our random tensor that we generated, and it's 3 by 2. Okay, and it's exactly as I said it would. Another thing, or would be. Well, thank you. I'm glad you are enjoying the video. It makes me very happy. And believe me, we're scratching the surface of the craziness, but I wanted this to be approachable to somebody that was a beginner. Don't worry, in about 3 weeks, we'll be doing things that are ridiculously complex. Now, how would you go and turn a NumPy array into a tensor? Something that's important, something you will do all the time. Let's just call it NumPy array, and you just say numpy.aRange. I would just want to generate this guy. I'm going to say that I want to generate values from 1 to 24. So I'm going to say aRange and 1. You have to put the 25. It goes up to 25, but doesn't include 25. What am I doing? I forgot my parentheses. Sometimes I talk and forget to type. Okay. And then you can also define what data type you want this to be. So I'm going to say data type is equal to, and this will be NumPy and int 32. To get rid of my parenthesis? Yes, it did. Okay, and then we can say NumPy array, like that. All right, so there it is, generated from 1 to 24, just as I said that it would. Now let's convert this into a tensor, and I'm just going to call this tensor2, just to be simple, and go tf.constant, and pass in your NumPy array, and guess what? Now you have a tensor. And there it is. You can see it's a tensor, but it's the same exact values. And also that we're using integer, 32-bit integers. Now let's say that you wanted to be able to change the shape of your tensors. How do you make your windows faster? I'm using, I don't know if I understand your question, but I'm using Google Colab is what I am using. And Google Colab does all the processing for all of this. So that's the reason why I'm using it. It's like Google's giving you its high-powered computers to be able to mess around with this stuff. It's pretty awesome. Syntruck, thanks for stopping by. Okay, so change the shape of my tensor. So if I want to change the shape of this, it is what I'm going to need to do is get a value of 24. Because I have 24 different pieces of data. So that means that the shape of what I'm converting into must ultimately be equal to 24. Let me show you an example what I'm talking about. So that means if I make it 6 by 2 by 2, well, guess what? That equals 24, and that is a valid valid shape change from this what we have right here. Now, if this was a 1, obviously this would be 12, and this would not work. Okay, so just make sure that whatever you're working with is going to be equal to 24. So let's make this 2, and this be 24. Just a little bit of linear algebra thrown in here. Believe me, linear algebra, trig, those are going to be what you need to understand more than absolutely anything. Not calculus. Okay, so I'm going to create a constant here, and I'm going to go np array like that, and I'm going to say that I want to change the shape 2 for this tensor that we are going to be creating here to 6 by 2 by 2. There it is. Tensor 3. Boom. And we converted it. If you want me to change this to 1 just to show you that it doesn't work, I will do that. See, it doesn't work. So this has to be 2. Or it has to be some version of rows and columns and sheets that are going to be multiplied together to equal 24. What do we want to do now? Well, you can get a whole bunch of different information. No, you cannot play games on Google Colab as far as I know. I don't know. Is there a way? There might be some weird way of programming something, and I don't know. I have no idea. I've never tried to make games on Google Colab. Okay, so let's say I want to get the first index of this. I'm just going to say, I'm going to show you a whole bunch of different ways of getting data. So I'm going to say index 0 like this, and tensor 3, and there, grab that. And what else would I want to get? Let's say that I also want to get the values for our dimensions of our vector. So I can say, I'm going to call this values in dimensions, something like that. I don't know. I think you get what I'm talking about. And you can just say tensor3 dot shape, exactly like that. Whoops, values. And what else can we do? I can also, let's say I just want to get the dimensions here. So we'll say dimensions like that. And tensor3 dot dimensions. And, oh, that's number of dimensions, sorry. Number of dimensions. And parenthesis. And what else do we want to get? Let's say the total values. So total values, and you can go TF dot size for tensor 3, and we convert this to numpy like that. And what else do we want? Let's say that we want to just get the data type. All right, so there's a bunch of different random things or types of information we can get about our tensors that are sometimes useful, sometimes not so much. Tensor3 dot dtype, I believe. Yes. And we are. Run it. Oops. Type something in wrong. As you can tell, I don't do this a whole lot. I mainly look at the. I don't look at that much in regards to how my tensors are set up. Oh, this doesn't have parentheses, I don't think. Yeah, there you go. So there's all the information you can get on that. Okay, so why is linear algebra and all this nonsense useful? Well, I'll just give you a brief explanation of matrix multiplication. You can do so many awesome things program-wise using matrices. I mean, and speed up the calculation of very complex things very, very quickly. Thank you for helping the person that's having trouble with their computer. Okay, so we got matrix multiplication. This is what we specifically refer to as finding the dot product between two matrices. I think this is pretty self-explanatory how it's going to work. You're going to have this matrix right here and this matrix right here. Now, what's important is that they are going to have to be opposite each other. So in this circumstance, we have 2 rows and 3 columns. Here, we are going to have 3 rows and 2 columns. All right? So what that means is the number of columns, 3, must be equal to, for the matrix on the left, must be equal to the number of rows for the matrix on the right. And the reason why is what we're going to do is we're going to take 1 and multiply it times 1 and then add it to 2 multiplied times 3 over here. See, we're multiplying these across, and then we ultimately get a value of 22, 28, and all these other different things. And you say, boy, that's really dumb. Why are we doing that? You might not say that. I just want to show you one brief example. So let's say these are going to be the number of different there's so many things you can do with linear algebra that are amazing, but I'm just showing you this one brief example. Okay, so let's say we sold 26 chocolate ice creams. This is 18 vanilla ice creams, 9 strawberry, 24 chocolate chip ice creams on Saturday. Okay, so I think you can see these are the different flavors, how many of those different flavors were sold on each of those individual days. This is how much a chocolate ice cream costs. This is a vanilla ice cream cost for strawberry and for chocolate chip. Okay, so what we're going to be able to do with these two matrices is we can find the earnings on each day with matrix multiplication. And you might say, well, how would that work? Well, I'm going to show you. Okay, so I'm going to take this data right here, and I am going to create a matrix. So I'm going to call this ice cream sales equal to TensorFlow, and this is going to be a constant, like that. And then I need to go and put each of those rows of data inside of here, and this is just the tip of the iceberg of awesome things you can do. This isn't even that awesome, but it's kind of awesome when it comes to working with matrices. Okay, and then I'm going to start getting into programming our models and all of that stuff to make predictions on our NBA salaries. But this isn't a learn-in-one video for TensorFlow by any stretch of the imagination, but it is about as much information as I think one person who's new to this stuff can understand in one video. Okay, so, and I'm going to try to make a new video, depending upon if you guys are interested or not, every single what is this, Wednesday? Okay, Wednesday. It depends on if you're interested. If you're not, well, then I'll make one every other Wednesday or something like that, or who knows. It'll all depend upon interest. Because sometimes things that I think are ridiculously interesting, other people don't. Actually, most of the time I think something's really interesting. Most of the world does not agree with me. So I don't know how that works in your life, but that's my life in general. Okay, so 8 and 6 and 14. Okay. So that is how many of each of the different flavors we had. And did I close all of my parentheses? Oh, I need one more bracket right there. Okay, so I just created all of those, and I can go and show you them. So ice cream sales, run it, there we are. Okay, so there is our first tensor, and then we're going to create another one that is going to represent the ice cream price, and make another constant like this, and our price for this is going to be 3, 2, 2, and 4 and 4. Is that right? And ice cream price, boom. There we are. 3, 2, 4, 4. Yes. Chocolate ice cream costs $3 a cone, vanilla, strawberry, and all that stuff. All right. So I went and plugged that information in, and how easy is it going to be now to be able to go and find multiple, how much money we were able to net, depending upon all of these different, on each of these individual days. I can just go TF and matrix multiplication and ice cream price and ice cream sales, and run it. And you can see right here that based off of that, how many different items we sold and the different prices for each of those ice creams, we were able to net $246. Obviously, this is made up data, but whatever, $246 on Saturday, and then Sunday, Monday, Tuesday, and so forth and so on. Okay? All right, so there we are. Went through a lot of stuff about tensors and all of these different things. Now we're finally actually going to start creating models and making predictions. Now you see something here that is extremely important, and it is called normalizing and hot encoding our data. Now remember what I said before about how all of our data is all messed up. So I'm going to come in here, and I'm going to go MBA data numeric, just to review. Okay. So what we're going to do is we are going to convert our non-numeric data into numbers, but all of our data is basically on completely different scales. Like I said before, we have for, I don't even know what MP is. Did we figure that out? Anyway, field goals. We have 265. Then for field goal percentage, we have 0.439. We have all over the place. This salary is 2,700,000. This is crazy. We can't work with data like this. So we're going to have to normalize our data to a common scale. And we can do this while also not distorting differences in the wide range of values. And we will convert all the values to between 0 and 1 while preserving their original distribution that they have. And I'm going to show you exactly how to do that right now. And then what I'm also going to do is, jump into actually creating models. So let's go and get rid of this. We know that our data is messy and not normalized. And by one hot encoding, what that means is we are going to take things like letters, like position and things like that, and we're going to convert those into numerics as well. Do you have it? I do not have any videos on OpenGL, sorry. Okay, so we have all of these different pieces here. And what I want to do is I'm going to go and convert all of these. So let's get this over here. And I'm just adjusting my window a little bit. Whoops, I don't want to do that. Adjusting my window a little bit so that I can see all the comments, because I have to look at comments on YouTube and also on Twitch. This is something that's a little bit weird. Okay, so what are we going to do here? I am going to one hot encode, and which means converting things like letters and non-numerics into a numeric format, and I'm going to normalize, which means I'm going to take all these other values and put them on a common scale of between the value of 0 and 1. So pretty easy to do. I am going to do a column transformation here. So I'm just going to call this CT. I'm going to call this make column transformer. And then what I'm going to do is let's go and put this on a separate line. I'm going to go min, max, scalar. And this is in our imports at the very top of the screen. So like the very first thing we did when we started this. And let's say that I want to just do a transformation on age and points. So I'm going to say age and points. So that means I am going to try to make predictions. What am I doing here? I'm going to try to make predictions based off of only the age of the player as well as the total number of points the player scored. So let's go like this, and let's go like this, and there we are. And what this is going to do is it's going to normalize the values in those two columns to values between 0 and 1. Okay. And what's up next? Well, one hot encoding, that means I'm going to convert things like letters and words and things like that into also numerics. So one hot encoder is what you use to do that. And I actually can't do anything because I don't have any, I'm not going to work with this, but I'm doing this so that you can see it. So I'm going to say handle unknown, I'm going to say ignore for this, and then what I'm going to do is I'm going to show you, let's say you kept position or team or something like that inside of your data set. I'm going to show you how to one hot encode it. So how you would do it is just come in here and do something like position. I would have to go back and redo all of this to make this work, so I'm not going to do that. So what I'm going to do instead, so this I believe is all covered, right? In max, making sure I closed all the parentheses. Okay, so what this would do for us is it would go and convert the age and points to a common scale between 0 and 1, and it would convert all the different positions like center and forward and all those different things into numerics as well. You could also put team inside of here. That was another one. I'm not going to do it in this video, but I'm showing you how to do it if you have data that needs one hot encoded. Okay? So I'm just going to leave that there. I'm going to copy this, and then I'm going to sort of tap that out, and then I'm going to paste this again. and I'm going to use just my numeric data here to analyze this. All right, so we have age and points. That's all good. And we can just go like this and that. All right, so, okay, there we are. We are going to normalize all of our data, right like that. Whoops, what did I do wrong? Did I have too many of these? I might have. Let's go. There, okay, so it worked. I'm going to go and add in even more data points as we continue here, but this is where we're going to stop. Okay, the next thing I need to do is I need to separate my data into features and labels. The features are going to be all the NBA player stats, and the labels are going to be one thing, which is salary, which is what we're trying to predict. So how you do that is also pretty easy. I'm going to label all the features as X because this is just something that is always basically done. NBA, and mainly these are going to be X and Y. So I'm going to come in here and I'm going to go NBA underscore data like that. And I'm going to be using NBA data instead of NBA numerics. I used numerics before because I wanted to. And in this circumstance, I'm going to be normalizing this data, so I don't want to do that. Okay, so I'm going to drop salary because that's the thing we're trying to guess. And I'm just separating the salary column data from the other ones. And these are what we call our features. So these are just the NBA stats. Okay, so that's what those are. I am also going to come in and I'm going to have Y. This is going to be the label or the salary. I'm going to say NBA data and salary. So there's salary. And this is going to be the label, or it's going to be the player salary. So we're taking all the NBA stats and we're trying to figure out what is the salary for the player based off of that information. Okay, so I got that. What do I need to do now? Well, I need to separate into training and testing data. What we're going to do is we're going to train our models on 80% of our data, and then we're going to use the remaining 20% of our known data, like we know this is correct, and we're going to have our model try to predict the last 20%. And then based off of that, we'll know how accurate our model is. So pretty awesome stuff. So how do we do that? How do we separate our training and our testing data? Well, again, I'm going to say the training is going to be 80% and the test is going to be 20%. We need training data. We also need testing data. Another problem with this data set is there's only about 350 data points in it. Now, I'll get more into why models work and why they don't work. That's not that much data. We would like to have more data. We always would like to have more data, but just giving you a heads up that is something. Okay, so I want to go and get my training data for our features, the test data for our features, and also the training data for our labels, and which is Y, and the training data for our test data for our labels. I think I said all that right. Maybe I didn't. I think you understand either way. So we're just going to go X and test and Y and train and Y and test. And there's a function that I imported earlier on, and it is called train and test and split. And you just give it your data. So that's going to be my features X, Y, my labels. I am going to say that the test size is going to be 20%, just like I think I explained pretty well. Size is 20. And then I am going to do random state. This is the random seed. Remember, if we ever want this randomness to be reproducible in the future, that's the seed. Okay? I think, did I do everything right? No, I didn't. I just don't see something. There's something wrong here. Oh, okay, I see. Train, test, yeah, I knew there was something wrong. Train, test, split is the name of that. Now it looks right. Let's run it. And it worked. Okay, so now what I need to do is I need to transform our training and our test data. And what are we going to be doing? Well, we're going to be using this stuff. up here. We're going to be converting our age and our points to normalized data. And then I'm going to come back and we're going to examine whether adding more data points is going to make our predictions more accurate or not. So I need to transform that data into normalized on the same scale. So how do we do it? Well, it's very easy actually. Oops, I got a drink. This is green tea. That's what that is. Kind of gross. I drink very thick green tea. Okay. So what we're going to do here is I am going to go CT and fit, and this is going to normalize our data and one hot encode our data also if we did that. So train like this, and then I'm going to transform the training and test data. So let's just go in here, and I'm going to go X train normal is what I'm going to call this, is equal to CT transform X train, and then I'm also going to do the test data normal equal to CT transform X test, and run it. Is that right? Oh, what'd I do wrong? CT fit X train. Oh, well, this is wrong. You guys should have caught me on that and said, hey, there's something wrong with your, that looks like a weird variable name. Okay, let's run it again. And there it worked. Okay, so our new data now that is normalized, and it would be one hot encoded if we set it up like that, is now going to look like this. So I'm going to say train and normal. And now you can see that the age, see, everything is in the same range. So instead of having, this is the age, good Lord, let's just get rid of that. But you see, you can see the difference between the age and so forth and so on. So it's all between the values of 0 and 1. All right, I'm not going to run that because it filled up my whole entire screen. It was impossible to see what was going on. And now we finally reached the part where we can build a neural network. And I'm going to take a brief break, and then I will be back and do so. And that will be the last break of the day. So I will be back in a second. All right, I'm back. I am going to get rid of this. All right, cool, it's gone. Okay, so, everybody can hear me? Good. Did you ever see a person drink so much green tea? I drink green tea like crazy. Like most people drink coffee. I can't drink coffee, actually. Okay, so build neural network with our training data. This is what we have been working towards. Okay, so I am first off going to set a random seed. I think everybody should understand why I am doing this. So I'm going to say random seed, random set seed, and I'm going to just make this 66. 66 has no importance. I can make this anything, so just so I can reproduce it. Now, neurons are, if you're wondering what a neuron is in a neural network, they're just nodes through which data and computations flow. I showed you previously, I don't have the slide here, but remember that pretty picture I showed you on the slide at the very beginning? That represents the neurons and the pathways through which they're flowing. Now what I want to do is I want to create a model and sequentially go through all of my data. I'm going to call this MBA model is going to be equal to, and I go TensorFlow, Keras, and if you want to sequentially, you can, there's multiple different, as we continue here, covering more and more, you're going to see multiple different ways of working with this data. Okay, get rid of that. Next time I will not have all these stuff popping up. Okay, so now what we're going to do, remember I talked about hidden layers? I am going to create 4 hidden layers, and if you can, what you should do is you should go through and you should actually play with this. This is one thing you definitely should play with. How accurate is the data if I use 1 hidden layer? How accurate is the data if I use 10? So, that's something to play with. Okay, so Keras like this, and what this is doing, remember, is it's taking our features that were import into this, and it is going to try to make sense of it, try to organize those features, that input data, the MBA player statistics, and convert it to a final salary. That's what the hidden layers do. And it's different. Sometimes having a lot of layers is good. Sometimes it is bad. There's something called overfitting data. And if you overfit data, what it'll do is it will very accurately convert features into a final price based off the training data, but then it'll be wildly inaccurate whenever we try to test that data. So, and I'm going to use activation here. And activation functions are going to help our network decide what of the data we provide to it is actually important. And what I am going to do, I'm going to go this. I'm going to be using ReLU. There's multiple different ones, and I will cover them as the tutorial continues. I will constantly cover all the different options you can use so that we can test and see which is the best for us. Why is activation? There it goes. Okay, and now I'm just going to copy this like this and make what I say. I was going to make 4 layers. I think so. So I'm going to make this 100 also, and 100, and the last one, this is just going to be a 1. And I'm going to get rid of this last parenthesis that is right here, and I think everything else is all set up. So what's going on, just to 100% explain what's going on when we create this model, is these hidden layers are going to receive the data. They're going to add weightings to the data to try to figure out which data provided is the most important to ultimately figure out what the salary for the player should be. All right? And how it does this, to be specific, is going to be depending upon the error. So let's say we take the age and the, what did we do? I forget now. Age and points, is that what it was? Age and points. So it goes and it gets age and points data, and it's going to say, okay, how much weighting should, and when I say weighting, how important is age or how important is points on a percentage basis to calculate the final salary amount. Okay, that's what it is. And if we do not add in this activation, it's just going to do a simple regression, which is just going to be a straight linear plot, which is something that we do not want. And ReLU, what that stands for is reactified linear unit. And it's just a function that is very computationally efficient in making its calculations. So that's why we're going to use it. Okay, so that is how we're going to create our model. Now, after we create our model, you can see the points of actually creating a neural network. We got to gather our data. We have to create our model, which is defining our hidden layers and such. And then we have to compile the model. And what it's going to do, the compilation of this is going to calculate errors. Wow, thank you very much for the donation, VexCode. I greatly appreciate it. It's going to calculate the errors, and it's going to optimize and also evaluate. Again, and what we're going to be using is the mean absolute error, and I might as well just go and create it. So I'm going to go MBA and model.compile, and here's our loss function. By loss, what I mean is how accurate are our predictions. So loss, like how much are we off with each of our predictions. So dot Keras dot losses dot MAE. There it is. There is mean absolute error. Just how much is our prediction off from the actual. That's what it's calculating. Then we're going to also define an optimizer, and there's multiple different optimizers. In this circumstance, I think that the atom optimizer is going to work well, but we should test other optimizers, and we shall as the tutorials continue. This is an extremely complicated concept you're learning here, so can't really be covered all in one video unless the video is, I don't even know how long. Here is our learning rate. And what we're doing, there's two main optimizers you're probably going to use. You're going to use SGD, which stands for stochastic gradient descent. And how it works is it's going to optimize our guesses by smoothing the predictions to our observed data, which means our actual salaries for our MBA players. And the atom is also going to do something quite similar. And what the learning rate is doing... This is starting to get a little bit complicated. Okay, so whenever we are, I probably should have a slide for the learning rate, and that would make it more sense. But what the learning rate is going to do is it is going to, how do I explain this? All right, so it goes and makes a prediction on an MBA salary based off of the data we provide, like age and points. What the learning rate does is it says, okay, well, whoops, we're off by a good bit. How much should we adjust our weighting for our next prediction? And the higher this number is, the quicker it will find an accurate prediction for salary. So 0.01 is a pretty high accurate or a high learning rate. It's very common to find something like 0 point like that. I'm just going to stick with this though right now just to test our results. So it's by learning rate, it's saying how much should we adjust our weightings for our next guess. All right. Now the problem with having a large learning rate is you might overshoot what your goal is in regards to predicting. However, if you have a very small learning rate like that, it's going to take longer to get to your desired prediction. All right. Hopefully that made sense. If it doesn't, you can ask me, and I will. Or you can just say that didn't make sense, and I'll try to explain it in another way. I should have had a slide for that. And the metrics that we are going to measure here is going to be our error. So this is going to be our mean absolute error. And that's going to say how much are we off with our predictions. Okay, so that's what the metrics part is. Okay, made our model. We compiled our model. Now we need to fit our model. So I'm going to call this fit data is equal to NBA if you have sound sample and I want to make a multi-label classification, I'm going to cover multi-label classifications in the next video. That's the next video that I'm going to make. And what that would be, an example of that was, let's say you had like a whole bunch of pictures of food and you wanted to only pick those pictures of food that had fish in them. Okay, so that would be multiple labels. So you could have like shrimp and cod and salmon, and those would all match. But if it was a steak, it wouldn't match. Okay, that's next video. Okay, learning rate makes sense. Why does the model training... Well, the model knows it's done whenever you tell it to be done, which is what I'm going to do right now. So I'm going to call this, I'm going to go NBA model and fit. That was a perfect question because that's what I'm providing. So what I provide here is going to be the training data for X, which is going to be normalized, and then the Y training and epochs, and I'm going to have that be 100. Now, or you can change this as much as you want. Basically what an epoch is it's a full iteration over our training data. So what we're saying here is we want to do a full iteration through our training data 100 times to try to make these predictions. And you're going to see how accuracy affects depending upon how many epochs we increase, because that's something I'm probably going to play with. And I'm going to say verbose no. All that means is I don't want, as it's creating all this, I don't want this stuff spilling all over the screen. Okay, so let's just do that. And sometimes this can take a couple seconds, but Google computers are pretty fast. If I would have taken verbose off of there, it would have shown that the model went. But you can see the check mark here, so that means that everything worked. Now, based off of this, I want to evaluate my model and see if it's any good or not. So I'm going to say MBA and model loss and NBA model MAE, which is going to tell us how much our predictions were off. And it's very easy to find that out. You just go MBA model and call the evaluate function. And all this code's going to be on GitHub probably an hour from now. I'm going to put it all up there. And do you guys like this? Do you like this, me doing live coding, better than my normal thing or not? Because I've been kind of considering actually redoing this tutorial in a live way also. I don't know. And also, one question I have for you viewers is the resolution truly better on Twitch than it is on YouTube? If somebody could tell me that, I would greatly appreciate that. I guess I can find out afterwards. Okay, so I'm going to run. And we could see that we are off by $4 million, which sounds horrendous. And it's not spectacularly good. But it, we're dealing with almost every NBA player is making $1 million. So it's off by 4 million. What we can do, however, is show how efficient our model was by coming in here and actually plotting the predictive capabilities as we go. Do you have any computer vision tutorial available? I don't have any yet. That's probably going to come not next week, but probably the week after is whenever I am going to do that. And I'm also entertaining doing a TensorFlow Lite tutorial also, where you can do like stuff with a Raspberry Pi. There's a bazillion things. All right, so what I want to do here is I want to plot to see how increasing the number of epochs is going to decrease my overall error. So I'm going to go plot and figure, and I'm going to change this to figure size. And do I want this to be 30 by 20? Eric Rosen was arrested for money laundering. I do not know if that's true or not. Eric Rosen is a YouTuber who does chess videos. I kind of doubt that's true, but I don't know. Anything's possible in this world. I think we all can say that anything is possible. Okay, so what I want to do is I want to plot my loss And remember, well, we made our prediction right here based off of two things: age and points scored. That's it. So we're going to take a look at what happens whenever we increase that to, we increase the number of epochs, and also when we increase the number of statistics we need to make predictions. All right, so I'm using Seaborn here. That's what SNS stands for. And I'm just going to do a simple line plot that's going to show how our accuracy improved with our model. And fit data dot history is going to tell us this. So we'll run that. And there you can see. All right, so when our model first started off, it was off by over $9 million. And you can see here it is going down, 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 down. And now we're off by about 5. So, hey, we did a lot for each different iteration through training. We went from 9 to 4 million. That's pretty good. What happens if we take this up to 200? Okay? And, you know, just so you remember, an epoch is a full iteration over our training data. That's what we got here. Okay, so I'm going to come in here. Let's run that. And then we could see if increasing the number of epochs is going to increase the performance of our model. And let's see. Yay, look at that. Now we're down to 3. Okay, so you can see now we went and dropped from 4 to 3. So that is pretty awesome. Another thing we can do is we can change what data we are going to be using for our model. Where is that? Where did I define that? Let's come up here. There we are. Here's more. So we're getting better and better. At what point is the model overfit or underfit? Well, whenever your results dramatically change. Thank you very much, Bobby Fisherman. I greatly appreciate it. Bits. But I do not know anything about Eric Rosen. I know who he is, but I don't know anything specifics about his life. You know, the YouTubers and all that, they have a tendency to get crazy sometimes with all their money. And I'm not saying that anything happened, but who knows? Okay. So just to speed things up here a little bit, I'm going to say, okay, let's see. Okay, so I just made our prediction based off of age and points. That's all I used. That's like no data at all. But if we come up here and look at this, and this is why charting all this information is extremely important. So we go age and points. Age and points. So here is age, 0.39. So it doesn't look like salary has absolutely anything to do with the age of the player. I just picked that randomly. Points most definitely does. And remember, 0.64, this guy right here, free throws. The number of free throws a player makes in a game is the highest. Okay, so what we can do now is we can take that different data and we can go and make changes. Now, did I lose everything? Okay. So what was it? Free throws? And I see, I wasn't paying attention. Okay. Well, let's see if I can outproduce a statistician, an expert on analyzing players. Okay, one of the most common things used to make predictions in regards to the quality of an NBA player is something that's called NBA efficiency. Let's see if the experts are better at making predictions than I am. Normally, I would guess yes, the answer would be true. So NBA efficiency, I have read. I am not an expert on NBA statistics, but whatever. NBA efficiency has a great bearing and is a great way of judging the overall capabilities of a player. Let's see if it's better than me being off about 3 million. Well, the major difference here is going to be the different things here. I'm just gonna copy and paste so you don't have to watch me do this. So I'm just gonna copy and paste. Okay. This is how the NBA judges. This is points. This is whatever that rebounds, TRB, I think. I don't even know. Steals, blocks, field goal percentage, free throw percentage, turnovers. Who cares? We got all that. All right, so we're just going to run that. That is how the NBA judges that. Now we have to run all this other stuff. So bear with me while I do that. I'm transforming everything here. compile our model. So I got to 3.7. And don't worry, my models are going to get much, much, much more accurate. It's just whenever you start off, if I started getting into weightings and things like that, this could go off the rails. So I just want to try to keep it. Okay. So I'm more efficient. I'm better at making salary predictions than the NBA experts, at least in that situation. Another thing, let's come in and let's say, well, what if we use everything? What if we use every single statistic to make player evaluations? Is that better? Well, we can just throw this in here and find out. So there's everything. There's every single statistic, and we know some of them are horrible in regards to correlation with salary, and some of them are very, very good. So we'll do that and run that. And we'll build our model, and we will test again. So here's our model. See how fast everything is? It's unbelievable. Okay, we ran it. Let's see if everything is better than the MBA experts. Oh, yes. So everything was better. We dropped down to 3.6 million, which is considerably better than what we had before. Do I have anything else? Well, I know that high correlated features like field goals and free throws, free throw attempts, turnovers, and points were all highly correlated to my salary. So let's try just doing those. I will grab it. High correlated features. So that's these guys right here. Actually, age was not something that was good. So let's throw this in here. Run it. And run it. And so everything is the best so far. So let's see if highly correlated is better. So we got 3.6. And as we make changes, our accuracy is going to continue to go up and up and up and up and up until we are really good. Okay. And look at that. That's kind of surprising. Actually adding only correlated assets actually made our accuracy go down. All right. So there's a lot of stuff. I think that if you watch this whole video and you completely understand it, you have taken a major step in regards to understanding how TensorFlow works. And anybody have any other questions? Has this practice of analyzing data with Python helped you make capital gains? Yes, we are going to eventually start applying all of this stuff to the stock market. Yeah, of course, for educational purposes only. I am not going to recommend any stocks. I only did that one time, and I got lucky, to be honest. Somebody dared me to pick a stock that would, this was in my Python for Finance video tutorial series. Somebody dared me to, they were like, oh, you don't know what you're talking about. If you're so smart, give us a stock prediction and see what happens. And I got lucky. Stock went up over 300% in like 3 days. So that was luck. It was some education, but it was also a little bit of luck. All right, so that's it. I guess everything was all right. I don't know. What do you guys think about this becoming is this an every Wednesday type of thing? Is this an every other Wednesday type of thing? What do you think in regards to that? I already told you I'm going to be doing, I'm going to be doing lots of things. In the next video, probably what I'm going to do is analyzing photographs and things like that and making predictions based off of whatever the photograph is. That's probably the next video. I don't know if that'll be up next week or not. Either way, thank you to everybody that joined me today. I normally hang around a little bit after the video's over to answer any other questions. Every other Wednesday would be nice. Every other Wednesday? Okay, I might do that. I might say that I will, not next Wednesday, but the Wednesday after that, I will do another video like this, and it'll be like a 2-hour video that covers crazy stuff. Any prerequisites for upcoming computer vision tutorials? A basic understanding of Python. That's what you need to understand. I'll structure the videos so that you will completely understand them as long as you understand Python. And just so you understand also, sometimes I just say, hey, this is a common formula that we use to do whatever. And just understand that. Like, you know, like I can either go deep into the weeds and require you to understand linear algebra and very, very complicated statistics and probability mathematics, or I can sort of just say, hey, in this circumstance, just understand this is a formula you use. You don't really necessarily need to understand every single thing that's going on with it, okay? And I think that's probably a better way of approaching that. Thank you very much for the donation. Bobby Fisher, man, you are the man. All right, thank you so much. I'd be interested in stuff like this. However, often you decide to upload them. I need an excuse to use one of them. All right, cool, yes. All right. So everything, thank you. Thank you, thank you. I greatly appreciate you guys. I hope you really understand that. And otherwise, I will catch you in the Wednesday after next. All right, thank you. Talk to you later. Bye.